Hello, everybody. This is Mr. Ainsworth, and we're going to get into rotations here, part three, where we're going to be rotating points and sets of points like triangles and such, either 90 degrees clockwise or counterclockwise about any point. Okay, so I'm going to highlight that because in our previous lesson we rotated about the origin, but today I am going to rotate about any point. So the center of rotation, or what we call the rotocenter, can be anywhere, not just the origin. This is a little bit different, and also we're gonna learn how to do it without the compass and without the protractor and without the trace paper. We're gonna learn how to do it using simple algebraic concepts like slope. Okay, so the very first thing of what I want to do is we need to recall the algebraic relationship between the slopes of perpendicular lines. Okay, what is it? What do you know about the slopes of two perpendicular lines? Well, I'm not going to tell you, so let's go ahead and analyze the slopes of some perpendicular lines and take a look at it. Okay, so let's research it, and then based upon the numbers here, come up with a conclusion here. So we start off with the definition of slope from a linear function. So let's write that down. Slope is equal to rise divided by run. You got to remember that the rise is the vertical distance and the run is the horizontal distance from point to point. So what we're going to do is we're going to use that simple definition. We're going to take a look at two lines here, line 1 and line 2. L1 and L2 stands for line 1 and line 2. We're going to take a look at their slopes by analyzing their rise and run and then compare. All right, and then we'll easily see the relationship between the slopes of the perpendicular lines. All right, so we got a couple points on both lines here. So on line 1, let's go from C to B. We can go rise and then run. So we're going to go up, okay, and then left. And if you do that, if you count, you go up 2 and then left 3, and that's a negative. So line 1 has a negative slope of negative 2/3. Okay, so let's write that down. So the slope of line 1, rise is 2, run is negative 3, so 2 divided by negative 3 is negative 2/3. All right, next line here, I got line 2. So we're going to go from B to A. Okay, so you're going to go up and right from B to A, and you're going to go up 3, right 2. Just count 1, 2, 3, right 2. So the slope of that line, well, it's different, right? It's rise 3, run 2, so slope of 3 halves. Oh, by the way, this is a video, right? So if you're at home doing this by yourself, learning at home, trying to catch up, and I go too fast, don't worry about it. You guys should be able to pause, play, and rewind. Okay, so remember that. Okay, well, back to the relationship here. What's the slope? The slope of L1 is negative 2/3. The slope of line 2 is 3 halves. We want to take these two slopes and compare them. What's the relationship between the two? Between negative 2/3 and 3 halves? Well, take a look. One's obviously negative, one's positive, so they're opposites. 2/3 is the reciprocal of 3 halves. Oh, so they're opposite reciprocals. Is that true for all perpendicular lines? Okay, so I don't know. Let's take another look. So here's another set of perpendicular lines. So let's call this one L1 and this one L2. Let's figure out L1 first. Okay, so we're going to go from B to C. So we're going to go up 1, right, right, let me see, up 1, right 5. So the slope there is rise 1, up, run 5, so 1/5. Okay, on the other line, from B to A, we got to go up 5, left 1, so it's a negative 1. So the slope there, well, let me see, that's 5 divided by negative 1. That's negative 5. So let's compare. Negative 5 compared to 1/5. All right, notice that they're opposite reciprocals again. Okay, so now it's pretty obvious, hopefully, after a couple examples here, that if the lines are perpendicular, their slopes are opposite reciprocals. And that, my friends, is the key concept. So let's go ahead and write that down and go for it. We just noticed that the slopes perpendicular, the symbol for perpendicular is the upside down capital T. All right, lines are opposite reciprocals. All right, and if you understand that, then this lesson should be pretty easy. Okay, so let's get right into it. In our first example here, we're going to rotate point A, which is at, left 2, up 4. Just checking something here. Okay, we're all good. So left 2 up 4, so negative 2 comma 4. We're going to rotate it about r, not about the origin. We're going to rotate it about negative 1 comma 1, 90 degrees clockwise. All right. And then secondly, we're going to rotate it counterclockwise. Thirdly, we're going to rotate, or we're going to label all the points of each point of our images. And then I'm going to draw the circle to verify that we're correct, and I'm going to show you how to measure the angle and make sure that it's actually a 90-degree rotation. All right, so the very first thing we ask is what's the slope from R to A? All right, so from R all the way to A. All right, and that should be pretty easy. You go up 3, left 1. So the slope here is up 3, left 1. So up 3, left 1, that's 3 divided by negative 1, or negative 3. Now what we need is the perpendicular slope, because we know that if we were going to rotate it 90 degrees, then it's going to be in somewhere on a perpendicular line 90 degrees either to the right or to the left, either clockwise or counterclockwise from A. So we need to take the opposite reciprocal of this. So the opposite reciprocal of that is positive 1/3. Okay, so you take the opposite in sign, it's got to be positive, and then you reciprocate 3 over 1 to 1 over 3. So you take the opposite reciprocal. You're going to be doing this on all your examples. Okay, so I encourage you guys to write down your slopes, make it easy for you to see. The question is, how do you use it? Okay, so what we're going to do is we're going to use the slope of 1/3. So put your pencil at R, and you're going to go up 1, right 3, up 1, right 3. So from R, so up 1, 1, right 3, 1, 2, 3, and there is A prime. Okay, it's at 2 comma 2. Now, if you want to see the angle and see that it's correct, you just draw the radius from R to A prime. And if you look at it, there's 90 degrees right here. And so we can see that it's a 90-degree rotation in a clockwise fashion. Okay? How do you get the other one? So what you do is just reverse it. So when I say reverse it, I'm saying instead of going up 1, right 3, we're going to go down 1, left 3. So just change the signs of both the rise and run. We're going to go down 3, left 1. So reverse the slope. Okay? So instead of going up 1, you're going to go down 1. Instead of going right 3, you're going to go left 3. So we're going to go down 1 and then left 3. 1, 2, 3, and we're right here. And we're going to call that A double prime at negative 4 comma 0. All right, and if you want to draw the vector or the radius from R to A double prime, you can see there's a right angle there. You can see it's right here. All right, and then furthermore, if you want to really see it, you're going to draw the circle with radius RA. So get your compass. I'm going to get mine. Okay, so let me grab my compass here. All right, let's bring it in. And the first thing I want you to do is adjust your compass so that the radius is RA. So adjust it from R to A. All right, easy. Okay, there we go, right there. So once you adjust your compass from R to A, you draw the circle, because we know that any rotation or any image, if it's rotated, lies on the circle. All right, so draw your circle, and you'll notice that A prime and A double prime lie on the circle, where A prime is your clockwise rotation, 90 degrees clockwise, CW for clockwise, and then A double prime, well, that represents your 90 degrees counterclockwise rotation. Okay? And that's all there is to it. So you can draw the circle to check to make sense. You can draw your vectors, which basically is the radius of the circle, from the point of rotation to the pre-image. This is your pre-image right here. This is the one we started with, right? So we call that the pre-image. And then you got your image here, A prime, and your image, A double prime. And notice how I labeled the coordinates. Let me highlight that. You label the coordinates here and here. I request that on all end results throughout this entire lesson. All right? And not only that, that's how we check our answers. Okay, you show me your coordinates, and it's easy for me to verify. So we took A right here. Come on. Oh, that's we're in another program. Hang on. There we go. We took A and we rotated it to A prime, and then we rotated it counterclockwise to A double prime. That's how it's done. So in reality, what we want to do is understand this idea of using slope so that we can do the rotations here rotate any point in either direction, clockwise or counterclockwise, without the compass, without a protractor, without a piece of trace paper, guys. We want to do it using the simple idea of slope. So you're going to see me write down the slope and its opposite reciprocal every time. All right, so let's do it a few more times because one example is not enough. We're going to rotate about R, again, 90 degrees clockwise and counterclockwise, and we're going to label the coordinates of each point, and then we're going to draw the circles to verify. Okay, I have to use different programs here to illustrate the idea, but you can do it on your piece of paper pretty easily. Okay, so the very first thing you do is you take a look at the slope from R to A. So, how do you get from R to A? That's basically what I'm saying. Okay, and you simply go up 2, 1, 2, right 3. Just take a look at it. So I can see that my slope is 2/3. And then you take the opposite reciprocal to get the perpendicular slope, which is -3/2. Okay, so then all you do is use it. So we're going to go down 3, 1, 2, 3, right 2. Okay, there's one image. So at 0, -1. All right, if you want to see the angle, just draw the radius from R to A prime. There's your 90-degree angle right there. That represents a clockwise rotation, 90 degrees clockwise. All right, like that right there. And then if you reverse it, just reverse the direction. Instead of going down 3, right 2, we're going to go up 3, left 2. See, this is the same fraction. -3/2 and 3 divided by -2, they're the same, guys. So you're going to go up and then left. So reverse it. 1, 2, 3, left 2. All right, and there's A double prime at -4, 5. So -4, 5. And then what we do is we get our handy dandy compass again. And let's see here. Let me just go for it again here. So let's line up. We'll go from R to A. Adjust properly here from R to A. That's as close as I'm going to get on the computer here. And then rotate. And you can see that my images, A prime and A double prime, lie in the circle. All right, and A prime is always 180 degrees from A double prime. That's another way you can check too. They should be opposite of one another on the circle. Why? Because there's two rotations apart, two 90-degree rotations. Okay, so then let me draw that vector so you can see it. So R to A double prime. See, there you go. You can see how A prime and A double prime, they're on opposite sides of the circle and they're 180 degrees apart because 90 and 90 is 180. What I'm talking about is that rotation right here. Okay, so that's always going to be the case. So A is at 1, 4, and it gets rotated to 0, -1, 90 degrees counterclockwise, clockwise, excuse me. And then here we got a counterclockwise rotation, so 90 degrees counterclockwise. That's all there is to it. Believe it or not, the numbers change, the slopes change, but the ID doesn't. Okay, so on this next one here, number 2, or the second example here, you want to calculate the slope from R to A, or A to R. It doesn't matter what point you start with. It doesn't really matter. Okay, so you go up to 1, 2, left 5, 1, 2, 3, 4, 5. So I can see that my slope here is up to left 5, or what I say just is a -2/5. My perpendicular slope is opposite reciprocal of that, which is 5/2. So what I want to do is go up 5, right 2. Up 5, right 2. From R now, from R. Always from the rotocenter. So up 1, 2, 3, 4, 5, right 2. There's A prime. And that is at 4, 6. And then you want to rotate it the other way. So you reverse it. So -5 divided by -2. Reverse both of them. So down 5, left 2. Down 5, left 2. So 1, 2, 3, 4, 5, left 2. And you're right here at A double prime at 0, -4. And then if you want to see I'm right, or you're right, okay, go R to A prime and then R to A double prime. They're 180 degrees apart because there's two 90-degree angles right here. There's 180 degrees apart. That should always happen. And then the last thing you should do, and you should because you're learning, all right, is you draw the circle. because these points of rotation better lie in the circle. Okay, okay. So you line it up. There we go. Let me go back over here. Gets this out of the way. Gotta line it up. No, 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 no. There we go. That's as close as I'm going to get it on the computer. And you draw your circle. And you take a look at it. Okay, notice that A prime and A double prime here are opposite sides of the circle, 180 degrees apart, 2 rotations apart. And so which is which? A prime is a clockwise rotation, A double prime is a counterclockwise rotation. Okay, so let's denote that. Okay, so here, from here to here, this is 90 degrees clockwise. From here to here, this is a 90 degrees counterclockwise. All right, next one. No, 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 no. Okay, now on this one, the rotocenter is here. Okay, I know there's 2 points here, but I'm telling you that. Let's put the rotocenter at the origin here and over on this one too. All right, we want to figure out what the slope is from A to R, and that should be obvious. Up 3, left 1, so the slope should be 3 divided by -1, which is -3. Perpendicular slope, opposite reciprocal, 1/3. Okay, so you go up 1, right 3, A prime, reverse it, make them both negative. Down 1, left 3, over here to A double prime, which is -3, comma -1. Over here, this is 3, comma 1. If you want to draw your vectors or radius, that's fine too, and then draw your circle. I'll leave that up to you. But this is 90 degrees, and that's 90 degrees. All right, so clockwise here. All right, counterclockwise here. Okay, so there you go. Okay, last one. Here, let me see, the slope here on this one is down 2, left 2, so -2 divided by -2, which is obviously 1. Opposite reciprocal of that is -1. Okay. So what we want to do is understand that, let me see, this is down 2, left 2. -1 is the same thing as -2 over 2, so down 2, right 2 would work. Down 2, right 2 would put you here at A prime. And you can see the right angle there. See, that slope is -1, and the other slope, AR, is +1. All right, and then you reverse it. All right, 2 divided by -2, so you go up 2, left 2. So up 2, left 2 would put you up here at A double prime. All right, so there's 90 degrees here, 90 degrees here, and you can draw this on your own, okay? The points are 2, -2, and -2, 2. So -2, comma 2. All right, now let's have some more fun here. Example 3, we're going to do a few things. Number 1, we're going to rotate it. Secondly, we're going to reflect it over the x-axis. We're going to rotate it clockwise and then reflect it over the x-axis. So here we go, 1 point at a time. So let's keep record of what we do. So from R to A, we got to go up 1, 2, left 3. Okay, so the slope there is negative, let me see, 2 divided by -3, all right, or -2/3. Perpendicular to that would be 3/2. So what you do is you go up 3, right 2. So up 3, 1, 2, 3, right 2, put you here. There's your A prime. All right, D. Now, D is horizontal with R, so the slope's 0, which means it's horizontal. It's 4 units to the left. And you should know that every horizontal line is perpendicular to the vertical. Horizontal, perpendicular to vertical. I mean, that's how these graphs are made. All these grids are made. They're all perpendicular to one another. So since D is 4 units from R, we got to go up 4 units. 1, 2, 3, 4, and there's D prime. Okay? And then E, well, let me see, E to R, you got to go up and right. Look at that. The slope from E to R or R to E is the same, right? It doesn't matter which direction you go. So up 1, right 2, that's a slope of 1/2. So for E, the slope is equal to 1/2. Perpendicular to that would be -2. All right. Or you could say 2 divided by -1. You can say either one. So the question is, which one do you need? So let's analyze. Let me clean this up so you can see it better. Okay, so if you use the first slope here, -2/1, you got to go down 2, 1, 2, right 1. But that would be a counterclockwise rotation, and we want clockwise. So this is counterclockwise. So let's go up to left 1 from R. So up to 1, 2, left 1. Ooh, that looks better because we're going to the right or clockwise. Okay, so this is actually E prime here, not down here. Okay, so we have E prime, we have A prime, we have D prime. So let's connect. And let's shade it in. This is my first image. So I started off with a pre-image here. This is, so I call that number 1, number 2. That's my second figure I have. That's my image. And now I've got to reflect it. I got to reflect the image, not the pre-image. You always do the whatever you end up with. Okay? Do it step by step. So here's the x-axis, as you guys already know. So we're going to reflect across it. So you count units from the axis. So E prime is 3 units above, so E double prime is 3 units below at 0, -3. And then D prime is 5 units above, so D double prime would be 5 units below. Ooh, not 0, -5. I'm saying I see 1, -5. And then A prime is 4 units above, so A double prime would be 4 units below A double prime. So 3, -4. And then you connect. Notice that the shape and the size of the figure does not change. These are isometries. Okay, so you're going to reflect the figure from here. You're going to reflect right down there. Okay, got to reflect the figure across the line of reflection. In this case, we got line of reflection is the x-axis. Okay, and that's all there is to it. And the end result right here, this is the end. So end result. When I send you guys the solutions, I always give you the end result. And I ask you guys to label the coordinates, number 3. So if you're not doing that, you better start doing that because I'm not signing your work unless you do. Okay? All right, number 4. We got to do a few things here, right? We got to rotate around counterclockwise. We got to reflect it across the y-axis. Thirdly, we got to translate it. And then fourth, we got to write down the end coordinates. Okay, so you have, a few things to work on here. And I'm going to change this a little bit. I forgot to change it for this presentation. This should be y minus 3 on the translation right here. So fix the translation. Okay, so let's get started here. We're going to rotate first 90 degrees counterclockwise. So let's do 1 point at a time. So working on A, the slope from R to A, that's up 1, left 4. So the slope is up 1, left 4, so -1/4. The perpendicular slope, you're going to use obviously 4. So perpendicular slope equals 4 or 4/1. So you have a choice. You can go up 4, right 1 for a clockwise rotation. Up 4, 1, 2, 3, 4 will put you up here. That's clockwise, but we don't want that. We want counterclockwise. So you reverse the 2 and you make them both negative and you go down 4, left 1. That's the opposite of up 4, right 1. So you reverse the direction. Okay, so put your pencil at R. You got to go 1, 2, 3, 4, left 1. There's A prime. Okay, B. B is from B to R or R to B. It doesn't really matter. You got to go up 2, right 5, or left 5, down 2. Okay, that's positive. So that's 2/5. So slope is 2/5. Perpendicular slope is -5/2. Or you can say 5 divided by -2. Okay, either one. You can put the negative sign anywhere you want. All right, same numbers, guys. It's just a negative fraction. Okay, a negative divided by positive is the same thing as a positive divided by negative. You guys should know that from grade school. All right, so here we go. We're going to see which one we use. We're going to go down 5, right 2 to see if that's good. So down 5, 1, 2, 3, 4, 5, 1, 2 to the right. That looks correct because right here, come on. We're rotating B. B is going in a counterclockwise direction. So there's your B prime. And then we got to do the C. From C to R is up 1, right 3. So the slope there is equal to 1/3. Or from R to C, you got to go left 3, down 1. They're both negative. Negative 3 divided by negative 1 is still, negative 1 divided by negative 3 is still 1/3. Perpendicular to that would be negative 3. Or negative 3 over 1, or 3 divided by negative 1. Depends on what you want to use. All right, I'm going to use negative 3 over 1. So down 3, 1, 2, 3, right 1, and there's C prime. Okay, 3 over negative 1, that'd be up 3, left 1. That'd be a clockwise rotation. So this is clockwise and this is counterclockwise. So I use this one. Why? Because the directions asked me to do it that way. Okay, so now you connect. So you go ahead and connect your primes, your images here, and you have your first figure that's been rotated. Now you got to follow the directions. You have to reflect it across the y-axis. So the y-axis is vertical right here. So you got to reflect it across this. Oops, I don't want to do that. You want to reflect it here, so this way. So A double prime is here. C prime is 3 units away, so C double prime is here. B double prime is 4 units away over here. Okay, so now you connect again. That's my second image. Okay, now you have to translate it. Translate means shift. All right. So I got to go right 1 and then down 3. That's what this translation means. Okay, x plus 1 means right 1 and then down 3 because y minus 3 as opposed to y plus 3. So right 1, down 3. So let's finish up here. So starting with C. So you go right 1, down 3. C triple prime, right 1, down 3. B double triple prime, and then A, right 1, down 3. That's A, excuse me. A triple prime, and then you connect. And that's your third image. Okay, so here are the steps. Step 1, we take our pre-image. We rotate it. We got the one in yellow, and then we reflect it across the y-axis. We got the one in blue, and then we translate it this way here. I'll show you the translation vector from B to B prime, double prime to B triple prime, C double prime to C triple prime, and then A double prime to A triple prime. So we translate it. So this is a fourth step here. This is my end result, and I need to state the coordinates. Okay, so A triple prime is 0, -4. And then B triple prime is left 2, down 3, so -2, -3. And then B, well, that was C. B triple prime would be left 3, down 5, so -3, -5. Okay, that's my end result. That's what I'm going to send out to you guys. Okay, and that's how I know if you're right or not. All right. Last one, number 5. We're going to perform the following transformations. Okay, in order. We're going to reflect across the x-axis, then reflect across the y-axis, then rotate it, and then translate it and see what we get. So let's reflect across the x-axis first. Okay, so here's the x-axis, y-axis here. So reflect first. So let me get some more room here. Here we go. So B is 2 units above, so B prime 2 units below. A is 5 units above, so we go 5 units below. And then C is 3 units above, so C prime is 3 units below, and then you connect. There's your first image. So you start off with a pre-image, here. And then you get this image here. This is your pre-image. The one you start with is always the pre-image. Then you reflect it, and you get an image. And then now we want to reflect it across the y-axis. Okay, and that's the vertical one. Everybody should know that. So you got to reflect it over here. So let's do that. So C double prime, A double prime, and B double prime. Yeah, B double prime here. And then you connect. There you go. There's my third thing, or the second thing I had to do, but the third figure, because we're starting to count and the pre-image is 1. And then reflect over the x-axis first, then over the y-axis, and then what does it say? It says rotate at 90 degrees counterclockwise. Okay, about R. So here we go. So from R to C prime, so C double prime, or from C double prime to R, we go up 1, 2, 3, 4, right 1. So the slope there is 4. So C for C prime, let me keep track of my work over here. C double prime, my slope here is 4. So slope 4, that means perpendicular slope is -1/4. So what I need to do is go down 1, right 4, or we can go up 1, left 4. Now, one of these is clockwise, one of these is counterclockwise. If I go down 1, right 4, down 1, right 4, you're going to be over here, and that's a counterclockwise rotation. Okay, so I need this one. So down 1, right 4, 1, 2, 3, 4, right here. So C triple prime. All right, it's a counterclockwise rotation. And then for B double prime, let me see. So R to B, so you got to go up 3, left 1. So that's -3. So the slope there is -3, perpendicular slope 1/3. So on that one, we can go up 1, right 3. What am I doing here? So which one am I doing here? So let me pause here. So did I count right? 1, 2. So -3, 1/3. So if I go up 1, right 3, I feel like I made a mistake here. Let me double check here. No, I'm doing it right. Okay, so on this one here, we want to rotate B double prime. So we're going to go up 1, right 3, up 1, right 3, 1, 2, 3. There we go. So I get B triple prime there. And then for C double prime, let me see, from C double prime to R. So I got to go up 1, 2, 3, 4, right 1. So the slope is 4. That means the perpendicular slope, -1/4. So on that one there, I go 4, 1, 2, 3, 4. I made a mistake here, something. Let me see. Okay, sorry about that, guys. I don't know what happened there, but uh, I overdid my stuff here. Um, so anyways, okay, so we're gonna rotate A double prime. So A double prime from R, so it's vertical. It's right underneath it. It's 1, 2, 3, 4, 5, 6 units down on this vertical line. And as we know, every horizontal line is perpendicular to a vertical. So we count 1, 2, 3, 4, 5, 6 units away from the rotation center, rotocenter. So then we count 6 units right. So 1, 2, 3, 4, 5, 6. Ooh, there we go. And that's A triple prime. So let's go ahead and connect there. And we should have the same triangle, but different shape. Okay, so there we go. We got the fourth figure here. And then what we want to do lastly, I don't know, let's read the directions here. We want to translate it. All right, left 2, all right, and then up 1. That's what that means. So you want to translate or shift, shift, slide, translate, all the same thing. Okay, left 2, up 1. So what do we get? We're going to go left 2, up 1. Let's see here. Left 2, 1, 2, up 1. There's B triple prime, 1, 2, 3. Ooh, quadruple prime, 4. At 3, comma 3. And then for A, you got to go left 3, up 3. 1, 2, 3, 1, 2, 3. Right up here. A quadruple prime at 5, comma 4. This is your end result now. Oh, I didn't do that right. Sorry. Mistake. I didn't count from the right spot. From A, 1, 2, 3, 1, 2, right here. What's going on here? I forgot my translation. I'm losing it. Left 2, up 1. Ah, left 2, up 1 here. There we go. So A triple prime, a quadruple prime, and that's 6, comma 2. There we go. Sorry, I'm losing it. And then what's the last one? You got to move C triple prime, left 2, 1, 2, up 1 right here. So triple prime here, and then connect. Okay, and there's the end result. Okay, and so C quadruple prime is 4, comma 1. So always write down your coordinates, all right, of your end result. And there we go, and that's my last figure, and this is figure 5. So 1, 2, 3, 4, 5. Okay, and I think that's it, guys. Yeah, it is. Okay, so like I said, this is a video here, guys. And if you need to review it, go ahead. If you need to see me on the side, go ahead and work on it with your classmates. Team up on it. Try to figure it out. And after a while, this becomes easy, okay, through a lot of practice, especially when the light bulb goes on. All right, so give it your best, and I will see you in my next lesson. This is Mr. Ainsworth, and I'm done with rotations today. I'll see you in my next lesson. Bye bye.